Good morning. Okay, before we go over the review, I wanted to go over some general information. So this is a review for a test you will take next Tuesday, May 14th. This test will go in as your last test grade before your final exam. It will be 40 multiple choice questions that mirror the 40 questions you will see on the review. You will also be able to make your own note sheet. Not a note card, you will get an entire piece of paper. You can fill out the front and the back if you so choose to. And whatever you add to your note sheet, you may use on the test. So let's work through the review together. So these first three problems are bringing us back to sine, tan, and sine. Hopefully this makes you think of your favorite acronym, SO, CA, and TOA. Our acronym of SO, CA, and TOA we learned at the start of the semester helps us identify and be able to use those special buttons on our calculator of sine, cosine, and tan. Remember, this helped us solve for missing sides and missing angles in a right triangle, a triangle with a right angle. In order to use your acronym of SO, CA, TOA, you have to remember that O stands for opposite, A stands for adjacent, and H stands for hypotenuse. So let's go ahead and see what we remember about SO, CA, TOA. Question number 1 says sine of blank is 7 over 25. You are being asked to fill in the correct letter. You are asked to identify the correct angle that makes 7 over 25 true. So remember, S stands for sine, and sine uses their acronym of SO, which means that 7 is supposed to be the opposite side and 25 is supposed to be the hypotenuse. So if I go in and if I label 7 as the opposite side and 25 as the hypotenuse, they want to know which letter makes this true. I am going to tell you what does not make this true. C. Why? Because 7 is not opposite to C. Instead, 7 is opposite to 24. So this question is helping you identify that B is the correct option. B is the correct angle because focusing on angle B, 7 is indeed the opposite side and 25 is always the hypotenuse, the side across from the right angle. So now they want to know, okay, given tan, remember tan is TOA, they want to know for which angle or which letter is 24 over 7 tangent. Remember, TOA is opposite over adjacent, so let me relabel our sides. Now we want to find out, okay, for which letter is 24 the opposite side and 7 the adjacent? Is it true for letter C, letter U, letter B? This would be true for letter C because given angle C, 24 is indeed the opposite side and 7 is indeed that adjacent or that touching side. Last one we're working through together is now they want you to fill in the fraction. Sine of angle C is the ratio given by which two sides. Remember, sine is SO, O and H. So we want to label using angle C, which of these numbers as our opposite? Opposite from or going away from C is 24, because I'm figuring out my O. Now I have to figure out my H. Your hypotenuse is always across from the right angle, which is why we go in and label 25 as H. So we are making a fraction with, instead of O over H, your opposite side has a length of 24, and your hypotenuse is 25. Come down and take a look at the next problem with me. They want us to solve for x. Again, you are given a right triangle, and you cannot use Pythagorean theorem to solve for side x, because you need to know at least two sides, and you only know one of them, which is why we're going to go ahead and use SO, CA, TOA, which helps us solve for sides and angles in a right triangle. So using angle 71, let's go ahead and label our sides of x and 14. Should x get an O for opposite, an A for adjacent, or H for hypotenuse? Well, going away from the 71 is our opposite side, but we are not given our opposite side. So instead, let's go ahead and label x as our adjacent side, across from our hypotenuse, or going opposite of our right angle. And so we end up using A and H. A and H uses ka. So this is how we know we are using cosine of, inside of your parentheses goes your angle. Cosine of 71 is equal to, instead of A, replace that with your adjacent side x. Instead of H, your hypotenuse, replace that with 14. So how do we solve for x? Remember, you want to get rid of your denominator in this case. So we want to undo a divides 14 by multiplying 14 on both sides. So that left-hand side turns into 14 times cosine of 71. And on the right-hand side, times 14 cancels out, divides 14. So all we're left with is x. When I go to type this in my calculator, I want to make sure my calculator is in the right mode. I click the mode button on the left, and I want to double check it's in degree. And it is. So I'm good. I hit enter a couple of times. Let's go ahead and type this in. 14 times cosine of 71. This is what I'm typing in. I smash enter, and so my final answer, let's round it to 2 decimals, 4.557. That 7 rounds this up to 4.56. Come down to picture number 5 with me. They want us to calculate perimeter. Remember, to calculate perimeter, you add up all your sides. We know most of our sides, 3, 6, and 11, but we are missing this 4th side. Notice they give you a right angle. In order to solve for that 4th side, we can sketch in a parallel line to the 6. If this side is 6, our parallel line is also 6. If this is 3, this chunk is also 3, which means 3 and 3, which means a total of 11. Take away this 3, tells us that this side is 8. Again, that came from a total side length of 11 minus that smaller part, which is 3. 3, 3, total of 11, take away the 3, tells you that this is 8. So how can we get this 3rd side? Well, I have now made myself a right triangle. Remember, you can solve for a missing side and a right triangle if you're given 2 of them by using the good old Pythagorean theorem. A squared plus b squared equals c squared. You have a right angle down here. I'm going to redraw that right angle up here because I have parallel lines. Remember, C is always your side across from the hypotenuse, which means we can replace A with either 6 or you can replace A with 8. And we are looking to solve for that diagonal, that hypotenuse, that's C. Okay, so let's go ahead and calculate 6 squared as well as 8 squared in our calculators. I want to solve for C, so let's go ahead and combine like terms. And then to get C completely alone, I want to get rid of that squared, that 2. So to undo a C squared, let's go ahead and square root. And this is how we end up getting that C, or that hypotenuse, that side across from your right angle is 10. So now we can go ahead and we can calculate our perimeter by adding up our sides. 3 plus 6 and then we want to add up this long side, which has an entire length of 11, plus this 4th side, which we just calculated was 10. Now we can add up all 4 sides to get a total perimeter of 30. Come down, take a look at picture number 6 with me. they tell us that we are looking at a square. Let me go ahead and quick sketch a square. Remember, a square has 4 equal sides. I'm going to go ahead and mark they are equal by using the same tick marks. 4 sides that have the same length. And it says that it has a diagonal of 10, and they want us to calculate the length of each side. So again, because a square has 4 equal sides, we know that if one of the sides has a length of x, then all of the sides have a length of x. A square, remember, also has a right angle. And so this ends up making a right triangle where we can go ahead and solve for the missing sides. So let's go ahead and start to set up Pythagorean theorem. Focusing on this right triangle, C is your hypotenuse. C is the side across from the right angle. Across from your right angle is your diagonal of 10. And so let's go ahead and replace A and B with x. X squared plus x squared. I drew that diagonal inside. Well, x squared plus x squared gives you 2 of them, 2x squared. And then we can write 10 squared as 100. To get x alone, you want to get rid of the 2. Again, that came from having 2 x squareds. And so we can get rid of this 2 times x squared by dividing by 2 on both sides. And so these cancel out. And so we are left with just x squared. And on the right-hand side, 100 divided by 2 in our calculator gives us 50. And then let's go ahead and square root this in our calculator because we want to undo an x squared by square rooting. And this is how we end up getting that each side is around. That 1 keeps it a 7. So x is 7.07. Let's take a look at number 7. Again, we are given a right triangle, and you want to solve for missing side x, but you don't know at least 2 of the sides. So we can't use Pythagorean theorem. So we are using SOHCAHTOA. Focusing on our 37-degree angle, let's go ahead and label our sides. X is opposite of 37, so x gets an O. They do not give you your hypotenuse, the side across from the right angle, so I'm not going to label it. There's nothing there. But they do give us a 15, and 15 is adjacent to or touching the 37. So O and A, we are using tangent, we're using TOA. TOA tells us that we are setting up the tangent of, inside of our parentheses goes our angle. Instead of O, we're filling in our opposite side with x. Instead of A, we're filling in our adjacent side with 15. Do you remember what we did in the last problem? We got rid of our denominator by multiplying on both sides. And we're going to go ahead and rewrite that left side as 15 times the tangent of 37. And on the right-hand side, times undoes, divides. So let's go ahead and start to type this into our calculator. To get x is 11.303. That 3 tells us it stays as a 0. This next problem is kind of like a true or false. Instead of solving for x, they want to know if this equation is the correct setup for this type of problem. Let's go ahead and check. If we were to solve for this type of problem, focusing on the 37-degree angle, what letter would x get? Opposite of 37 is x, so x gets that O. 15 gets the letter H because it is across from the right angle. It's your hypotenuse. So using O and H tells us we are using sine of, inside of the parentheses goes your angle, your opposite side is x, your hypotenuse is 15. But our equation is different from the one they gave us. So is cosine the correct setup? Well, let me go ahead and check actually. I realized they gave us a 53. Erase. Sorry. I think I might have just scrambled your brain. I should have read this problem. So they give us a 53-degree angle instead of 37. Remember, a full triangle adds up to 180 degrees. We know that one of the angles is 90 and the other angle is 37. Let's go ahead and solve for the missing angle using our knowledge that a full triangle makes 180. Our total of 180 minus our two angles of 90 and 37 tell us that the missing angle is indeed that 53 degrees that is in the problem that I did not see before. I'm sorry. And so now they want us to focus on the 53-degree angle. So 53 is our reference angle. So what letters do X and 15 get? Well, 15 is still your hypotenuse. It's still the side across from the right angle. And now, not using the 37, but using the 53, X is adjacent to the 53. X is touching that 53. So A and H, we are using we're using cosine of, inside goes our angle 53 equal to our adjacent side, X divided by our hypotenuse 15. And these two equations match. So yes, this equation can be used to solve for X. Number 9, they give you a couple of different angles to choose from. They give you the 30, they give you the 60. You can decide on which of those you want to use to solve for X. Let's say you choose to use the 30. Now you want to go ahead and label X and 8 with the appropriate letters. 8 is the hypotenuse. It's the side across from the right angle. So 8 gets an H. Focusing on the 30 degrees, X is opposite of 30 degrees. And so O and H tells me I am using, so we are using sine of, inside our parentheses goes our angle. Our opposite side, opposite from 30 degrees is X. Our hypotenuse across from the right angle is 8. To get rid of that denominator, we multiply. Times cancels out divides. So let's go ahead and start to plug this into our calculator. We get X is 4. Number 10, they give you a word problem. They want us to draw a picture. It says a 14-foot ladder is placed 4 feet from a building, and they want to know the angle that the ladder makes with the ground. Believe it or not, this ends up making a right triangle. Typically, when you lean a ladder against a wall, a ladder's not flat on the ground. It's also, when you lean something, the ladder's not completely vertical. It's hard to climb something going straight up. Typically, when you lean a ladder against a wall, it's on a diagonal. So the 14-foot ladder is your diagonal. It's placed 4 feet from the building. Imagine this is your building, this is your ladder. The bottom of the building to the bottom of the ladder is 4 feet. And they want to know the angle that this ladder is making with the ground. Ladder, ground, building. So focusing on our angle X, ladder to ground, let's go ahead and label our sides of 4 and 14. 14 is the hypotenuse. It's the side across from the right angle, so it gets an H. 4 is adjacent to or touching the X. So A and H tells you are using ka, you are using cosine. Cosine of, you don't know your angle X, is equal to your adjacent side of 4 divided by your hypotenuse of 14. So instead of multiplying or dividing, X is inside the parentheses. To get X outside of the parentheses, remember, you don't use cosine anymore. You use super fancy inverse cosine. To get this super fancy inverse cosine in my calculator, I hit the second button, second cosine, gives me this fancy inverse that allows me to solve for an angle. It helps us get X outside of the parentheses. And so x is 73.39. 8. That 8 rounds this up to 73.4. We have another perimeter problem. Let's go ahead and start to add up our sides. We know that we have a side of 8 and a side of 5. So let me go ahead and keep track. Perimeter 8 plus 5. Let's go ahead and add up some more sides. It says this side is 5 and 4. But they do not give us a number next to this next side. But notice these two sides they kind of look the same length. They're both vertical. They look to be parallel, which is how we know this side is also 5. This next side, it tells us, is 3. They do not give us this long side. However, this long side matches up to this left long side. This left long side is made by the 8 and this 2. 8 plus 2 tells us that this entire side would be 10. They also don't give us this next side. However, we know parts of it. This little part would match up to this little part, which would be 3. This little part matches up to this little part, which would be 4. This next part does not match up to the entire 5. Instead, 5, but we are not looking at this 2. 5 minus 2 tells us this next chunk is 3. So we have plus 3, plus 4, plus 3. And then they give us these next 2 chunks are 2 and 2. And then we can go ahead and add all of these up to get our perimeter. Let's do some area questions. You can find these area formulas in your notes. I've written down the formulas, super handy for us. I would also recommend you include these formulas on your note sheet. Remember, an area of a parallelogram is given by b times h, base times height. Which of these numbers is your base? 10. Which of these numbers is your height? 9. Remember, height has to be perpendicular. Height needs a right angle. The diagonal can never be your height. Height has to be perpendicular. Let's take a look at the next problem. Triangle. Include this area formula in your notes too. Which of those problems is your base? 12. Which of those numbers is your height? Not the 5. 5 is the diagonal. Height has to be perpendicular. I'm looking for the right angle. Next to the right angle, that is why 4 is the height. Not the 5, not the 6. Triangle, divide by 2. Let's go ahead and plug this into our calculator. 12 times 4 divided by 2. 24. Let's keep it moving. Come down to number 14. We are looking at a trapezoid where you have B1 plus B2 because you have 2 bases. One of your bases we know to be 6. But we don't know the entire length of the bottom base. I'm going to go ahead and redraw this dotted line on the right side. This top chunk that is 6 matches to this bottom chunk, which is also 6. And then because it's isosceles means 2 equal sides. If this is 10, the right side is also 10. If this is 5, this chunk is also 5, which is why your top base is 6, and now we can get our bottom base by adding up all these numbers. 5 plus 6 plus 5 gives us an entire bottom base of 16. We do need our height. 10 is not the height. 10 is a diagonal. We're looking for that right angle, but there's no number there. We can go ahead and solve this by using a right triangle. You are solving for a side in a right triangle where you know two of the sides. I'm going to go ahead and start to set up Pythagorean theorem. Across from your right angle is your C, your 10 squared. So we can go ahead and fill this in with h squared plus 5 squared. Five squared, I'm replacing with a 25. 10 squared, I'm replacing with 100. To get h alone, let's go ahead and move this 25. 100 minus 25 gives us 75, and then let's go ahead and square root this. .66. Now we can go ahead and replace our height. Let's plug this into our calculator. Don't forget you do need parentheses. If you forget your parentheses, your calculator is going to put out something funky. Oops. Including our parentheses, we get a final area of 95.26. Couple more problems to get through. We are looking at a rectangle. Remember, a rectangle is given by base times height. Our base of our rectangle is 16, but our height is x plus 4 because you have two things. Remember, Mr. G recommended you put parentheses around them. It says that the area is 192, so we can go ahead and set our area formula equal to 192. So what would I do from here? There's a couple of different options. You could distribute and multiply, or because you have times, we can go ahead and undo times using divide. Divide 16 on both sides because I want to get x alone. 192 divided by 16 tells us that this turns into a 12, and like I said, divides undoes times, so this cancels out. So all you're left with is x plus 4. And then to get x completely alone, we just got to move a plus 4 by minusing 4 on both sides. These next couple questions bring us back to circles. Go ahead and write down your area of a circle formula as well as your circumference formula. If it says that the circumference is 20 pi, go ahead and set 20 pi equal to your circumference formula. Notice there is a pi on the left and a pi on the right. Let's go ahead and cancel them out. To get r completely alone, let's go ahead and undo 2 times r by dividing by 2, which is how we get that r is 10. And now that we know r is 10, we can go ahead and write down our area equation and replace r in the area equation with a 10. 10 squared tells us that now that we've calculated the radius, our area is 100 pi. This next problem says that you are looking at a square with a perimeter of 40. Remember, perimeter comes from adding up all 4 sides. If all 4 sides together make 40, we can go ahead and take 40 and divide it or split it into 4 equal sides. When we split a total of 40 into 4 equal sides, it tells us that each side is 10. Again, that came from taking a total of 40 and splitting it up or dividing it into 4 equal sides. Now we can go ahead and plug this into our area formula. Area of a square is given by base times height. The base of your square we now know is 10, and the height of our square we now know is 10. 100. Let's take a peek at question 18. The area of a rectangle is given by base times height. You do not know the base of your rectangle, so we need to go ahead and solve for that. But we do know the height of our rectangle is 6. This ends up making a right triangle where we can go ahead and solve for the missing side. If this is 6, the right side is also 6. And let's go ahead and solve for our base. We can solve for this using Pythagorean theorem, solving for a missing side in a right triangle, because we know 2 of the sides. Across from your right angle is 10, your hypotenuse, which means that we can go ahead and replace A and B with X and 6. Plug 6 squared into your calculator. Plug 10 squared into your calculator. To get X completely alone, let's go ahead and move the 36. And then we can go ahead and get X completely alone by undoing X squared by square rooting, which is how we get X is 8. And now we know the base of our rectangle. And we can go ahead and fill everything in our area formula. Couple more questions. Let's take a peek at question 19. They want the area of just the shaded region. So we want almost all of our rectangle, except we want to take away this triangle. So to find the area of our rectangle, we are using base times height, where this rectangle has a base of 15 and a height of 7. So this shape has an entire total area of 105. But we want to take away the triangle. So let's go ahead and find the area of this white triangle next, given by base times height divided by 2. Based on these tick marks tell us that 2 things are the same size or the same length. So if this side of the triangle is 9, the side that has the same tick mark is also 9. That's how we know that the base of the triangle is 9 and the height of the triangle is also 9. Why am I not using Pythagorean theorem to get the third side? Because the hypotenuse is never the base or the height. So the triangle has an area of 40.5. So we are looking at almost all of the rectangle, a total area of 105, except we want to take away that blank empty triangle that is not shaded. We want to subtract that triangle to get that the shaded region is only 64.5. Last question that I'm doing with you is a hexagon. Remember, your area formula for a hexagon that has 6 sides is 6 times s squared root 3 divided by 4, where s stands for your side length. So if you write down the area formula for a hexagon on your note sheet, you should be good to go, because you can go ahead and replace s with a side length of 10. Let's go ahead and plug this into our calculator. I'm only going to type in the numbers that are outside of the square root. So I'm only going to type in these right now. 6 times 10 squared divided by 4 gives us 150 root 3. And then I'm also going to write this as a decimal, just in case. 150 root 3. Ooh. Add examples to your note sheet, add formulas. You can do this.